In this section, issues with electrical connections will be discussed. Have you ever looked at your car battery and noticed that the terminals are corroded? Are you looking because your car won't start? Your battery terminals may need cleaning in order to reduce the resistance built up in the terminal connection due to the corrosion. The same thing can happen if terminals become loose. Connection resistance increases if the terminals are loose or corroded. The result is heat loss, in other words the I²R loss, in the connection and reduced current flow to the load. The message is, keep your connections clean and secure. Terminal screw connections are very commonly used when building a chassis. They are also used in house wiring in light switches and wall plugs. After stripping the wire, you use a pair of needle-nose pliers to bend the wire into a loop. You place the loop over the screw and turn the screw clockwise to tighten the connection. The crimp connection originated in the 1930s. It is still in common use today. The crimp connection utilizes a high-force compression press to hold a wire and a terminal together. The wire used must be multi-strand type that is simply stripped and clean. A wire tinned with solder must not be used, and a solid wire must not be used. Terminals used in stripping come in many shapes and sizes and perform different functions. Some are ring and spade lugs like those shown in this chart. Some are used in connectors for the contacts. The crimp tool, the wire size, and terminal connector must all match in order to get a good crimp. Splicing wires is a key skill for a technician. Here are two ways to splice a wire. Once the wires are joined as shown, they can be either soldered or capped. Solder is an alloy of tin and lead. The lead to tin ratio determines the strength and the melting point. Wire type 60/40 tin/lead is recommended for most electrical and electronic work. The item being soldered must be cleaned of dirt and oxide, otherwise solder will not adhere to the splice. Soldering flux prevents oxidation of the copper surfaces by insulating the surface from air. Acid and resin-based solders are available. Acid-based solder should not be used for electrical work because it corrodes copper wire. Resin flux is available in paste form or as a continuous core inside solder wire. This should be used for copper wire. When splicing wires that are part of a multi-conductor cable, stagger the splices so they don't all occur at the same point in the cable. This will avoid a large bulge in the completed cable. Making a terminal connection begins by looping the wire through the hole, bending it with a pair of needle-nose pliers, applying heat, and then solder. Conductors come in many sizes, shapes, and construction. Here are a few of the common forms. Recognize the lamp cable on the right, which is a pair of stranded wires sharing a common insulation sheath. Wires come with all sizes of solid conductors, stranded wire. Cables are available with multiple wires wrapped in a single insulator. Use the correct wire for your application. Remember that when crimping you must use stranded, non-tinned wire, and before soldering you must make sure the wire is clean, flux applied, and tinned. Bending a cable in too small a radius can cause immediate problems and other problems that do not manifest themselves until much later. Examples of problems are connector failures and high losses in fiber optic cable. The general rule is that the bend radius must be at least 10 times the diameter of the cable. Each cable manufacturer may specify its own bend requirements. You should follow the manufacturer's recommendation if provided. Bend radii are often given in short-term and long-term use environments, so you will have different bend radius requirements depending on how long the cable will be employed in a particular situation. Just remember that the standard bend radius for most work, including NASA, is 10 cable diameters. Wire sizes are specified according to the American Wire Gauge or AWG standards. This standard applies to the diameter of the wire conductor in a cable. The diameter of the wire increases as the gauge size decreases. Two basic requirements determine the size wire you should use in an electrical application. The first is the current that must be carried, and the second is the allowable voltage drop in the cable over its length. You determine the maximum resistance that can be tolerated by dividing the allowable voltage drop by the specified current. You then go to a standard wire chart and pick a wire size that can handle your current and has a loss per foot that does not exceed your maximum resistance.